Welcome students, welcome back to the series of lectures on matrices. In this lecture, we will try to do some problems on matrices. First problem, let P be an invertible matrix with I plus P plus P square up to P power n equal to 0, that is 0, that is the 0 matrix. So, what is given is that when you add I, P square up to P n, what you get is the 0 matrix. Find P inverse. What you are given, the data that is given to you is that P is an invertible matrix and it also satisfies the following, that is when you add I, P square up to P power n, what you will end up is a 0 matrix. Let us try to find the solution to this. In fact, I should say find P inverse in terms of so what is given is that I plus P square up to P power n, this is 0. Now, given that P is invertible, that means P inverse exists. So, let us multiply. So, multiply this equation by P inverse, then what we will have is that P inverse plus P inverse plus I plus P plus up to P power n minus 1 is going to give me 0. So, this will imply P inverse is minus I minus P minus up to minus P power n minus 1, right. So, this is the inverse of the matrix, so which is equal to minus of summation 0 to n minus 1 P power I. Let us do the second one. Next problem, if A equal to 1 2 1 5 2 6 minus 2 minus 1 minus 3, find A cube. So, we are given that A is 1 2 1 5 2 6 minus 2 minus 1 minus 3, right. Now, let us try to find A square. A square is 1 2 1 5 2 6 minus 2 minus 1 minus 3 times 1 2 1 5 2 6 minus 2 minus 1 minus 3, which is equal to 1 into 1 plus 2 into 5, which is 10 plus minus 2, 2 plus 4 minus 1, 1 plus 12 minus 3, 5 plus 10 minus 12, 10 plus 4 minus 6, 5 plus 12 minus 18, minus 2 minus 5 plus 6 minus 4 minus 2 minus 4 minus 2 plus 3 minus 2 minus 6 plus 9 minus 2 minus 6 plus 9. which will give me 11 minus 2, which is 9, 6 minus 1, which is 5, 13 minus 3, which is 10, 15 minus 12, which is 3, 16 minus 6, which is 10, 17 minus 8, which is 18, which is minus 1, minus 7 plus 6, which is minus 1, minus 6 plus 3, which is minus 3, minus 8 plus 9, which is 1. So, let us try to find out A cube, which is A square into A, which is going to give me A square is 9, 5, 10, 3, 10, minus 1, minus 1, minus 3, 1 into the given matrix A, which is 1, 2, 1, 5, 2, 6 and minus 2, minus 1, minus 3, which is equal to 9 plus 25 minus 20, 18 plus 10 minus 20, 9 plus 30 minus 30, 3 plus 50, 3 plus 50 plus 2, 6 plus 20 plus 1, 3 plus 60 plus 3, 1, so I will have minus 1, minus 15, minus 2, minus 2, minus 6, minus 1, minus 1 plus 18 minus 3. 36 minus 20, which is 16, 38, sorry 28 minus 20, which is 8, 30 gets cancelled, you have 9, 55, 27, 66, minus 18, minus 9, 14. So, this is A cube. Next problem, the set of natural numbers that is n is partitioned into arrays of rows and columns in the form of matrices. As M1 equal to just the first one single, M2 is 2, 3, 4, 5, M3 6, 7, 8, 9, 10, 11, 12, 13, 14 and so on. Right, the first matrix consists of just one element 1, the second one consists of 4 elements, the 2 by 2 matrix 2, 3, 4, 5. Wherever we are left with, the next one is the first element of the next matrix. So, M3 is a 3 by 3 matrix, right, 6, 7, 8, 9, 10, 11, 12, 13, 14, because 5 is the last element for M2. So, the next one is 6, it starts with, in general Mn is a n by n matrix whose first element is the next element corresponding to the last element of the a n minus 1 element of the Mn minus 1 matrix. Fine. Now, the question is this: find the trace of Mn. Solution. Now, let us write down the first elements of each one, right. So, these are all the first elements of each matrix. The first element in the first matrix is 1, 2, 6, 15, it goes, and then, well, one can notice that it goes, well, we will come back to that. One can notice that the difference is going to be just a square, that we will notice. So, let me denote by Tn the first element, general first element. So, 0, so let Sn equal to 1 plus 2 plus 6 plus 15 up to Tn. Therefore, 0 equal to Sn minus Sn. So, let me write Sn as follows: 1 plus 2 plus 6 plus 15 up to Tn. Well, you have the same thing, 1 plus 2 plus 6 plus 15 up to Tn, which will give me. Now, let me write this 1 separate, 2 minus 1 plus 6 minus 2 plus 15 minus 6 up to Tn minus 1 minus Tn minus 2 plus Tn minus 1 plus Tn. Sorry, I will have a minus Tn over here, right. Therefore, so which is equal to, let me write down, which is equal to 1 plus 1 square plus 2 square plus 3 square up to Tn minus 1 minus Tn. Therefore, so this is my 0, your right hand side, left hand side is 0 and I have this as the right hand side. Therefore, Tn, let me bring this Tn to the other end, Tn is 1 plus 1 square plus 2 square plus 3 square up to Tn minus 1, which is equal to 1 plus, well, one can notice that the difference is always a square, 1 to n minus 1 I square, I equal to 1 to n minus 1 I square, which is given by 1 plus, we know the formula, right, which we must have done in when we do this principle of mathematical induction. One can verify that this is going to be n into n minus 1 into 2n minus 1 whole upon 6. So, this is the first element. So, Tn is the, this is the first element for the mnth matrix, right. Now, therefore, so let A11 denote the first element of Mn, then A11 is given by 1 plus n into n minus 1 into 2n minus 1 whole upon 6. Now, the next element is just plus 1 plus 1 plus 1. So, what we wanted is all aii, right, for 1 less than or equal to I less than or equal to n, this is what we wanted, but one can notice that the next element, the difference between the next element and the, or for example, the difference between A22 and A11 is just n plus 1, that is the difference, right, the difference is just n plus 1. So, ith element is just n 1 plus n into n minus 1 into 2n minus 1 upon 6 plus I times, sorry, I minus 1 times n plus 1, right. I will just write it as 1 less than or equal to I less than or equal to n, right. If it is 1, you will get the same element, right, other things you will get it as and when, right, because the difference between any two elements is just n plus 1. Any two consecutive terms, that is a11 and a22, the difference is just n plus 1, or more generally the difference between ai and ai plus 1 I plus 1 is exactly n plus 1, and therefore, this is the general ai once you know a11. So, what we wanted is the trace of mn, therefore, trace of mn equal to summation 1 to n aii, which is given by summation 1 to n 1 plus n into n minus 1 into 2 n minus 1 whole upon 6 plus I minus 1, this is I running from 1 to I minus 1 into n plus 1, right. So, let me just split this term sum into two terms 1 to n, 1 plus n into n minus 1 into 2 n minus 1 whole upon 6 plus summation I equal to 1 to n I minus 1 into n plus 1. This is just a constant term, which means summation I equal to 1 to n just 1, which means I will end up with n times 1 plus n into n minus 1 into 2 n minus 1 whole upon 6. This is just a constant n plus 1, I will just pull it out, plus summation I equal to 1 to n I minus 1. So, I minus 1, which is equal to n into 1 into n into n minus 1 into 2 n minus 1 whole upon 6 plus n plus 1 into, well, this is same as I equal to 1 to n I, sorry, n minus 1 I, because I can just pull out I equal to, I replace I by I minus 1. So, that I will have I as, so the 1 gets replace I by I plus 1. So, that it turns out to be from 0 to n, but then the 0, so here you will have 0 to n I, okay, but then the term corresponding to 0 is just 0. So, I will have 1 to n minus 1 I, which is equal to n into 1 plus n into n minus 1 into 2 n minus 1 whole upon 6 plus n plus 1 into, so we know that summation 1 to n I is n into n plus 1, it is only up to n minus 1. So, n minus 1 into n upon 2, n into n plus 1 upon 2, therefore, replace n by n minus 1, you have n minus 1 into n upon 2, which is going to be, let me just pull out n by 6 throughout. I will have 6 plus I have 2 n square. So, I will have 2 n cube minus 3 n. So, minus 3 n square plus n, again I have a plus n minus 1 into n plus 1, which is n square minus 1. So, 3 n square minus 3 n, this is what I have, n by 6 into, the first term is just 2 n cube, 3 n square gets cancelled, minus 2 n plus 6, minus, oh, I have pulled out an n outside. So, I have an n outside. So, I haven't pulled out an n outside. So, what will I have? 2 n cube minus 3 n square, sorry, 3 n square remains. So, this 3 n square gets cancelled, and then terms regarding n, I will have only just plus 2 plus n 6 minus 3 is just 3 plus 3. So, this is the final solution. Therefore, trace of Mn is n by 6 into 2n cube plus n plus 3. Next problem, if A equal to minus 1 plus I root 3 upon 2I, minus 1 minus I root 3 upon 2I, 1 plus I root 3 upon 2I, and 1 minus I root 3 upon 2I, and f x equal to x square plus 1. Then find f of a. So, what is this f of a? Wherever there is x, just replace x by a. That is what this f of a means. Solution. So, what is f x? So, given that f x is x square plus 1, and therefore, f of a is a square plus identity, right. 1 is replaced by the identity matrix. So, now let us try to calculate a square. Minus 1 plus I root 3 by 2I, minus 1 minus I root 3 by 2I, 1 plus I root 3 upon 2I, 1 minus I root 3 upon 2I into minus 1 plus I root 3 upon 2I, minus 1 minus I root 3 upon 2I, 1 plus I root 3 upon 2I, 1 minus I root 3 upon 2I. If you look at 1 by 2I is a common thing. So, let us pull it out in both the things. So, what you will finally end up here is minus 1 by 4, because I square is minus 1, times minus 1 plus I root 3 minus 1 minus I root 3, 1 plus I root 3, 1 minus I root 3 into same thing, minus 1 plus I root 3, minus 1 minus I root 3, 1 plus I root 3 and 1 minus I root 3. This is what we have. We have minus 1 by 4 into, let us try to multiply. So, you have minus 1 plus I root 3 whole square minus 1 plus I root 3 whole square. Similarly, this into this, you have a plus b into a minus b is a square minus b square, but you have an I. So, a is 1 plus 3 this into this, and similarly here a plus b into a minus b, which is a square plus b square plus 1 plus 3. Again this into this, again you have a plus b into a minus b. So, the negative so you will have a square minus b square, right. So, a square is here a square, it is going to give me it will give me minus over here, fine, a square minus b square. right. A square is 1 minus of b square, which is I root 3, which will give me fine, and here a square will give me 1, while b square, no, a square is I root 3, so minus 3, and b is a square minus b square. Fine, I have this, and here a square, which is minus 3 minus b square, so minus 1 plus this into this plus 1 plus 3, and then finally this into this, what you will have is minus of 1 plus I root 3 whole square into 1 minus I root 3 whole square, right. Let us try to calculate. So, minus 1 by 4 into, if you try to expand this, what you will have is 1 minus 2 I root 3 minus 3 minus 1 minus 2 I root 3 plus 3. So, this is going to give me 0, again here I will have a 0. So, here I will have a plus, right, this into this plus, I have a plus, minus 1 minus 2 I root 3 minus 1 minus 2 I root 3 minus 3 plus 1 minus 2 I root 3 so I have minus 3, which is going to give me minus 1 by 4 into this one, this gets cancelled, this and this gets cancelled. What I will have is minus 4 I root 3 0 0, this one and this one gets cancelled, this is going to be plus, and similarly these two gets cancelled, and I will have minus 4 I root 3, which will just give me I root 3 0 0 I root 3. Now, let us try to calculate f of a. Therefore, f of a equal to a squared plus I. What is a square? A square is just I root 3 0 0 I root 3 plus 1 0 0 1, so will give me 1 plus I root 3 0 0 1 plus I root 3. This is what I have. Let us do the next one. Next problem. If a equal to 2 minus 2 minus 4 minus 1 3 4 1 minus 2 x is an idempotent matrix, then find the value of x. What is an idempotent matrix? A matrix A such that A square equal to A is called an idempotent matrix, or whenever you have a square matrix A which satisfies A square equal to A is called an idempotent matrix. Now, first let us try to find A square, which is A into A, 2 minus 2 minus 4 minus 1 3 4 1 minus 2 x times 2 minus 2 minus 4 minus 1 3 4 1 minus 2 x, which is equal to 4 plus 1 4 plus 2 minus 4 minus 4 minus 6 minus 8 minus 8 minus 8 minus 4x minus 2 minus 3 plus 4 2 plus 9 minus 8 4 plus 12 plus 4x 2 plus 2 plus x minus 2 minus 6 minus 6 2x minus 4 minus 8 plus x square, which is equal to 2 minus 18 minus 4 minus 6 plus 8, right. There should be plus 8. So, you have minus 2 minus 16 minus 4x minus 5 plus 4 is minus 1 11 minus 8 which is 3 16 plus 4x 4 plus x minus 8 minus 2x minus 12 plus x square. What is given is that A square equal to A, right. What is given is that A square equal to A. So, that means what do we have, that is 2 minus 1 4 plus x minus 2 3 minus 8 minus 2x minus 16 minus 4x 16 plus 4x minus 12 plus x square. They should be equal to 2 minus 2 minus 4 minus 1 3 4 1 minus 2 x. Just by comparing, what we obtain is that 16 plus 4x should be 4, or equivalently 4 plus x. When you divide this by 4, implies 4 plus x should be 1, right. So, that will give me x equal to minus 3, that is 1 minus 4, which is minus 3. So, let us do the next problem. Suppose a matrix A satisfies a square minus 5a plus 7I equal to 0 if a power 5 is 5a plus bi, then find the value of a and b. Solution. Now, we are given that a square minus 5a plus 7I is 0, and also what is given is that it also satisfies a power 5 is a times capital A plus b times the identity matrix. So, we will have to find the values of a and b. Now, let us try to express. So, well, before we go to the so given a square minus 5a plus 7I is 0, that will imply that a square is 5a minus 7I. Now, let us try to write down a cube, which is a square into a, and we know that a square is 5a minus 7I times a, which is equal to 5a square minus 7a, which is equal to 5 into 5a minus 7I minus 7 times a, which is equal to, you have 25a here minus 7 minus 7a, which will give me 18a minus 7I. So, we have expressed a cube in terms of a. Now, let us try to calculate a power 5, which is a cube into a square, a cube which is 18a minus 7I into a square, which is 5a minus 7I, 18 into 5, which is 90a, 18a minus 7I, 126 I a, this should be a square a and then you have minus 35a plus 49 I, which is equal to a square. I know that it is 5a minus 7I minus 126a minus 35a, 160. So, this is 161a plus 49I, which is equal to 450a minus 630I minus 161a plus 49I, which is equal to 10 minus 1, it is 9, 14, 14 minus 6, which is 8. So, you have 3, 3 minus 1, it is 2. A minus 10 minus 9, just 1. We have 13, 13 minus 4, which is 9, 5, 591, 10, 1. Sorry, this is 2, so this should be 8. Times identity. But on the other hand, what is given to us is that, so given also we are given that a power 5 is small a times capital A plus b times identity, right. So, let me call this as 1 and let me call this as 2. Comparing one and 2, we get small a equal to 289 and small b equal to minus 581. Let us do the next one. If a equal to alpha 0 1 1 and a square equal to identity, then find alpha. Solution. So, we are given that a square equal to identity. So, to use this, let us try to calculate a square which is equal to alpha 0 1 1 times alpha 0 1 1, which is equal to alpha square 0 alpha plus 1 1. So, we are given that a square is identity, that is alpha square 0 alpha plus 1 1, this is equal to 1 0 0 1. So, now if you compare these two matrices, what you will have is alpha square equal to 0 and alpha plus 1 is alpha square is 1 and alpha plus 1 should be 0. So, this will imply that alpha equal to minus 1. So, alpha equal to minus 1 is the solution. Next problem. If a equal to alpha 0 2 3 and a square is 9i, then find alpha. Solution. Again you are given that a square is 9 and 9i, which means you will have to find a square which is equal to alpha 0 2 3 times alpha 0 2 and 3, which is equal to alpha square, second term is 0, 2 alpha plus 6, sorry 2 alpha plus 6 and then the last term is 9. Now, we are given that a square is 9 times I, that is the two matrices, matrix alpha square 0 2 alpha plus 6 9 equal to 9 0 0 9. So, what we have is alpha square is 9 just by comparing the coefficients, and similarly this one you will have it as 2 alpha plus 6 equal to 0. So, these two together will imply that alpha equal to minus 3. So, alpha equal to minus 3 is the solution. Let us do the next problem. If x times y if this is equal to 1 by 3 times 1 1 1 1 1 1 1 1 1, then show that x equal to y by 9, sorry 1 by 9y, 1 by 9y. Solution. What we are given is that xxx, when you multiply it with y, the resulting matrix is just 1 by 3, 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 1 by 3. This is what is given. Now, let us try to find out what the left hand side is. If you look at the left hand side, it is just the multiplication of matrices with entries just equal to x and y respectively, right. These two are the matrices. Which is equal to 3xy throughout, right, xy, xy, xy. So, you will have 3xy throughout. Fine. If you compare with the given equation with the first one, what we obtain is that 3xy equal to 1 by 3. That means xy equal to 1 by 9, or equivalently x equal to 1 by 9y. Let us do one more problem. If the equations x minus 2y plus 3z equal to 0, minus 2x plus 3y plus 2z equal to 0, minus 8x plus lambda y equal to 0, have non-trivial solution, then find lambda. Solution. So, let us write the augmented matrix or the coefficient matrix, because your constant term matrix is just 0. So, 1 minus 2 3 minus 2 3 2 minus 8 lambda 0. This is the constant term matrix. Now, let us try to convert this into its row reduced echelon form. Let us try to convert this minus 2 and minus 8 into 0. R 2 is replaced by R 2 plus 2 times R 1, R 3 is replaced by R 3 plus 8 times R 1. 1 minus 2 3, because the first row is unaltered. Second one, R 2 minus 2 plus 2 times 1, which is 0, 3 plus 2 times minus 2, which is 3 minus 4, which is minus 1, 2 plus 2 times 3, so 2 plus 6, which is 8, minus 8 plus 8 times 1, this is going to give me 0, lambda minus 16, right, lambda plus 8 times minus 2, which is lambda minus 16, 0 plus 8 times 3, which is 24. Now, let us try to multiply this row into 1, so that you will make this into this minus 1 into 1. R 2 is replaced by minus of R 2, 1 minus 2 3, 0 1 minus 8, 0 lambda minus 16, 24. Let us try to convert these two elements into 0. R 1 is replaced by R 1 plus 2 times R 2, R 3 is replaced by R 3 plus 16 minus lambda into R 2. So, the first two columns are just going to look like 1 0 0 0 1 0, fine. R 1 3 plus 2 times minus 8. So, 3 minus 16, which will give me minus 13. The next one is remains unaltered. Next one 24 plus 16 minus lambda into minus 8, right. This is what I am going to have. So, let us write it down, 1 0 minus 13, 0 1 minus 8, 0 0 120 128. So, minus 128 plus 24. So, you will have 8 lambda minus 104, right, 8 lambda minus 104. Now, I want what is given is that the system has got a non-trivial solution. If the system has got a non-trivial solution, which means that the rank of the coefficient matrix should be less than 3. So, if you want the rank to be less than 3, this 8 lambda minus 104 should be 0. So, for the existence of a non-trivial solution, lambda minus 104 should be equal to 0. Therefore, 8 lambda minus 104 is 0, that will imply lambda is 104 upon 8, which is equal to 12. Sorry, 13, which is equal to 13. Thus, lambda equal to 13 is the only value for which the given system will have a non-trivial solution. So, if lambda is not equal to 13, if you just look at the previous one, this 8 lambda minus 104 is going to be non-zero. So, that you can divide this by a because it is non-zero, you can divide by that and you will get as 1, and you can make the other things into 0. So, that what you will end up with is a trivial solution, because what you will have is an identity matrix. In that case, the only solution that you get in this case is just going to be the 0 0 0 solution, which is a trivial solution. So, for the existence of the non-trivial solution, the only possibility is that lambda should be equal to 13. Thank you all.